Hi there, welcome to my channel and Happy New Year. If you're new here, you're welcome again. Feel free to subscribe. I hope your holidays are amazing and that you got the chance to relax or unwind or just take a break. It has been a very long past year. So today we're gonna look at another coding problem and let's do this. Today's question are gonna look at happy numbers, and this is a very common Leetcode interview question, and it is common with companies like Google, and in fact in the year 2019 it was Google's most commonly asked interview question. So definitely you'd want to make sure that you know how to approach this problem and that you know how to solve this in case you're asked the question in an interview. The question here is that we're supposed to write an algorithm which will determine if a number n is happy. And these are the steps of determining whether a number n is happy. You will start with any positive integer and replace the number of the sum of the squares of its digits, and then you'll repeat the process until the number equals 1 or until it loops endlessly in a cycle which does not include 1. So numbers which their process end with 1 are happy, and numbers which do not end with 1 are not happy. So basically you'll return true if n is happy and false if it's not a happy number. And we're given an example here. 19 is a happy number because the process ends with 1, and 2 is not a happy number, and that is why we return false. So we're gonna go ahead and look at the basic approach first and get an understanding of how happy numbers work before going ahead to look at the code solution of this. So for example, we have 19, and just to explain how we arrive at the fact that 19 is a happy number, so we're going to have 1 squared plus 9 squared, which will give us 82, and then we're also going to have 8 squared plus 2 squared, which will give us 68. We're also going to have 6 squared plus 8 squared, which will give us 101 squared plus 0 squared plus 0 squared, which will eventually lead to 1. So as explained before, happy numbers are numbers that will lead to 1 whenever this process is done. So basically 19 is a happy number. And what we are required to do is that we are supposed to go ahead and have an algorithm that will perform this process and check whether the final result is 1 or not. And if the final result is 1, it's going to go ahead and return true. And otherwise it's gonna go ahead and return a false. So we're going to go ahead and write the code of the process that I just described, and basically what we want our code to achieve is that we want to get the desired result, and in this case we want to get a true if our number is a happy number and a false if our number is not a happy number. So I'm going to have another function and I'm going to name it square sum, and I'll use the variable num, and I will initialize a variable with 0, and I need to make sure that my number is a positive integer, so I'm gonna use a while loop. So while num is greater than 0, I am going to go ahead and do a couple of operations down here which I'm going to explain once I finish writing the code. So let's do this. So this is the code, and basically what it means is that this first function here will do the first step of getting the first sum. So in this case we're going to go ahead and get the modulus of 10 and then square the modulus and add it to the result. So this first function here will give us the first step, which is getting this sum here. So and then we're going to need a set. So a set will always store unique items, as you know in the properties of sets. We're going to make use of sets and ensure that our result is not in the set, and that is the function of this while loop here, in that we're going to check whether while square sum of n is not in scene, and n in this case case is the given number. So while this result is not in the set, we're going to go ahead and create a variable and call it sum1, for instance, and have square sum n, so basically the function. And then we're going to go ahead and check the result and see whether it is equal to 1. And if it is equal to 1, we will return true. And otherwise, if not, we're going to go ahead and add the sum1 to the set, and then after that we're going to go ahead and equalize n to sum1, and then we're going to keep doing the function. So basically it's going to go back here, and we'll keep looping, and our function is gonna keep checking until we get the result. So if we go ahead and check the code, as you can see, our code works and it gives us the desired result. And when we go ahead and submit it, we can see that our code has been accepted and it is faster than 81%, and that is actually quite good. And we're also making good use of the memory. And yeah, so that is how to go about this problem. It's quite simple, and I hope you've learned something from it. So yeah, thank you so much.